Hello guys, my name is Vishasu and I'm here to talk about one of the important subject, digital electronics. Now in digital electronics, whenever we are talking about circuits, there are two kinds of circuit which have been used. The one is the combination circuit, the other one is the sequential circuit. Now whenever we talk about the combination circuit, actually it depends upon various factors due to which it is called combination circuit. First, in this combination circuit, the output will always depend upon the present state of input, not the previous state. So that is the difference between combination circuit and sequential circuit. The second thing is, in combination circuit, there will be interconnections of inputs and logic gates, which actually make a particular circuit viable. Now, whenever we are talking about the viability of that particular circuit, in this scenario, there will be n inputs and m outputs. If there are n inputs available, so there is a possibility that 2 to the power n possible inputs are always available. That is a scenario in combination circuit. Now, if you are talking about 2 to the power n, let's just say, if you are talking about one input, then the possibility that the possible inputs will be to the power n, and that is 2 to the power 1, and that is 2. So 0 or 1, like this. So whenever we are talking about number of inputs, the possible inputs will always be depend upon this particular number. Now each input and output are the particular variables, and they will have a particular value, because at the end of the day they are analog signals, and these analog signals will have significant particular amount of value. Now what is the value in this? Now that value will be defined as plus 5 volt or 0. 0 volt, whenever we are talking about plus 5 volt, that will be interpreted as one logic 1, and 0 volt will be defined as logic 0. Now in this scenario, every combination circuit will be described by m Boolean functions. Here m is the outputs. So how to make a particular combination circuit? Now if we are talking about a particular combination circuit, there is a procedure. And what is that procedure? When we are talking about a particular combination circuit, first what we need to do is we need to define number of inputs as well as number of outputs. Now any number of inputs and any number of outputs can be defined in a particular manner, but their output and their combinations will define that particular combination circuit. Now the second thing is we need to assign a particular symbol to those variables. Like in this scenario, we have given them n and m. Again, these are just the values which are provided, these are the symbols which have been provided, so that we understand the difference between those inputs and outputs. The third thing is we need to derive a truth table based upon these particular inputs as well as outputs, because truth table will give us the idea what is the relationship between inputs and outputs. After this, we need to implement simplification process. In the simplification process, what we do is POS, that is product of sums, and SOP, that is sum of products, as we have already studied. Then when we are talking about sum of products, when we are talking about products, that is x dot y, that is a product. And if you are saying a particular function is defined like this, x1 y1 plus x2 y2 plus so on, then it is called sum of products. But if a particular number or this particular logic has been defined as a1 plus b1, a2 plus b2 or so on, then it is called product of sums. It will actually make the particular logic circuit easy. After this, when we implement this and we have a SOP or POS form, a simplified form, then we go for implementation of that particular logic circuit. Now, what are those logical circuits which we have been talking about? Now, in logic families, there are so many functions which needs to be done. So what we do is we need to define them, whether it is an arithmetic circuit or it is a non-arithmetic circuit. In the arithmetic circuit, as we all know that in arithmetic circuits, what we need to do is adding and subtraction. Adding, when we are talking about adders, it is of two types. Basically, it is of two types, but numbers of types are available. Now, there are half adders, there are full adders. We use half adder. Same with the other subtractor. In the subtractor, there are half subtractor as well as full subtractor. Whenever we are talking about half subtractor and full subtractor, the difference is same like in adders. Now, there are non-arithmetic functions, non-arithmetic circuits that can be implemented by this logic too. Now, there are code converters. In code converters, we have binary to gray converters, gray to binary converters, we have BCD to XS3 converters. These are just the codes which have been frequently used in digital electronics. Now, there are comparator circuits out there. What we need to do is, in the comparator circuit is, we need to understand that there is a difference between the magnitude of those particular inputs. So, by comparator circuit, we actually help them to understand which one is bigger and which one is less, to compare them. Then, multiplexer circuit is there. In the multiplexer circuit, what we need to do is, multiple inputs will be channeled and actually sent for a particular channel. Then we use multiplexer. The same thing happens at the receiver side, but the opposite process. When we need to retrieve that inputs, what we do is demultiplexing. Same with decoder. Encoder and decoder are the two circuits which is used quite frequently in any kind of communication system. Now, in digital electronics, when we are talking about decoders and encoders, encoding done at the transmission side and the decoding done at the receiver side. That is the general process which we need to do. Now, in the next week, we will talk about half adders and full adders. Thank you. Various logic combination circuits and how they have been implemented. But the first arithmetic logical circuit will be the half adder. In half adder, what we need to do is we need to add two numbers and take output of those two numbers. Now, whenever we are talking about two numbers, those two numbers will be two logical numbers. So, the first we need to define inputs. So, there will be two inputs. As per procedure, there will be two outputs. Two inputs are called AND as well as AND. The first one is AND and second one is AND bit. Output will be symbolized by sum and carry, S and C. In the half adder circuit, there are only two bits which are available to us. So, as we already taught that number of possible inputs will be 2 to the power n. 2 to the power n, and that is 4. So 4 input variables will be available to us. Now A and B will be inputs and S and C are the outputs. Now the 4 combination which can be shown in this truth table: 0 0, 0 1, 1 0, 1 1. These are the 4 possible input which can be used in half adder circuits. Now, whenever we are adding 0 and 0, the sum will come as 0, carry will come as 0. It is a simple logical function that the two numbers are added and the sum will come of 0 and 0 is always 0, and there is no carry, so 0 will be there. Now, when we are adding 0 and 1, AND bit is 0, AND bit is 1. The sum will 0 plus 1 is 1, and there will not be any carry, so it comes as 0. Again, when AND is 1 and AND is 0, the sum will come as 1 and carry will not be available to us, that is 0. Now, in the last scenario, when two inputs A and B are both at logical 1 state, 1 and 1 is there, so output or sum will be 0, because whenever we are adding two numbers, they will always carry a particular number, and that is that is designated as carry. So sum will be come as 0 and this number will carry in the equation. So 1 will be the carry. Now when we see this for combinations and these outputs, we can understand what we need to do is we need to understand and make logical circuit. Basic logical circuit. The first we need to identify the sum and carry, and we need to make it in SOP or US form. So we will do that. Now the sum comes at 0 into scenario, and this is A bar B, and this is A and this is B. We need to write this sum as in A bar B plus AB bar. Now to simplify this logic, this is the XOR gate operations. So we can put it as A XOR B. The second thing is carry. It is coming when both the inputs are 1. So it can be written as AB. This form is called sum of products, SOP. These are SOP forms. Now when we get this SOP forms of sum as well as carry, what we need to do is implement that logic. So to simplify that particular logic, there are two inputs A and B. What we need to do is A XOR B. A XOR B, and that will be shown as sum. AB will be shown as carry. You've done it. It is a simple logic implementation, but you can show it in a different manner too. Like it is A bar B plus AB bar. So we can do this like this scenario. If two numbers are there, now what is that? A bar B. Whenever we are talking about A bar B, A bar B is the AND gate, right? A bar B, AB bar. These two are AND gates and AND, and there is plus sign available to us, so that is OR gate. So sum can be shown like this, and carry can be shown like this manner. A, B, and gate, and that is shown as carry. Now it can be shown using NAND gate logic implementation, where we can see this A bar B plus AB bar can be implemented like this: A bar B plus AA bar plus AB bar plus BB bar. As you all know, the BB bar, AA bar's values are 0. Nothing. So when we simplify this logic and we take this A, it is called A bar plus B bar plus B, A bar plus B bar. So we can see A bar plus B bar and A plus B. So it can be shown as like this. Now A plus B is there. So A plus B is there, OR gate is there. A bar B plus B is there again, and there will be AND it like this. So this is the NAND gate implementation of half-adder circuit. What we can do in your leisure time is you can actually extract the NOR gate explanation of NOR gate implementation of half-adder circuit too. Thank you guys. Now the second adder is the full adder. As you all know that in half-adder there are two bits which are actually summed or added. In full adder there are 3 bits which are added, which can be added, and the logic circuits can be understood by this diagrams as well as these two tables. Now first of all, as we all know the procedure of any logic gate implementation in combination logic circuit, then we need to identify inputs as well as outputs. So there will be 3 inputs and 2 outputs available to that. So 3 input bit is A, B and C, which are called AND, addend and carry bit. This is AND bit, this is addend bit, and this is carry bit. the output will be the sum output as well as carry out, C out. Now, as we all know that if 3 bits are available, so number of combinations which can be done in this particular circuit are 2 to the power 3, and it gives us the 8 combinations, 8 possible input combinations which will give us the output. Now, what are those combinations? A, B and C, again, addend and carry. 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0 and 111. These are the 3 bits which needs to be added. Now when we add 3 zeros, output will come as sum as 0 and there will not be any carry, so C out is 0. Again, when 0 0 1 is added, the out sum will be 1 and C out is 0. But whenever there are 2 ones, like in this circuit or this logic, the sum will be 0 but carry will be 1 due to 2 logic ones in this particular logic. Again, when there is only one bit that is logical high, then output is sum is 1 and carry is 0. It will be followed till now, till this moment. In the last, when this we have the again bit as 1, addend bit as 1 and carry bit as 1, the sum will be 1 because 1 plus 1 will be 0, there will be a carry, and 0 plus 1 is 1, so there will be a sum that is a logical high function and there will be a carry due to this particular logic. So carry will be available to this. So when we see this particular circuit, the sums which are on the higher side, 1, in SOP form, we will take this 1 2 3 4, that is 1 2 4 7. 1 2 4 7 are the sum, and it can be shown as A bar B bar C plus A bar B C bar plus A B bar C bar plus A B C, as we can see from this particular table. Afterwards, if we solve this, this is the XOR gate of all 3 logical inputs, A XOR B XOR C. Again, if you are talking about the carry out, this is the carry out, AB plus BC plus CA. If we are unable to process this one, we can put them as X, I and J too. So there will not be any confusion between C out and C. In this, C out will be shown as AB plus CA XOR B. Now, if you want to implement that particular logic in the logical diagram, what we can do is the simplest form, like this is A, this is B, this is C. 3 inputs are available and 3 inputs will be absorbed, and this will come as S2. Again, if we are talking about AB plus BC plus CA, we take this one is AB, then BC, BC, and then CA. This is CA. It is a simple circuit, and we put OR gate. This comes as C out. So this is the simple logical representation of sum and carry out in full adder circuit. Now it can be shown in a different circuit too. If we want to implement full adder using 2 half adders, this can be done too. We will draw it. Now if you want to implement two half-adder circuits available to this, then A and B is there, and XOR, this will be A XOR B. Now this is AB. Again this will be A XOR B XOR C, and if we take this, this will come as A XOR B dot C, and this is AB plus C, A XOR B, and that is shown as carry out. So what we can see is, this is one half adder and this is another half adder, back to back, to implement a full adder circuit. So there is a possibility that if you want to add two numbers, and if you want to implement a full adder circuit using two half adders, this can be done, and it can be shown as and in block diagram as well, like this half adder one that carries there, this output will go to half adder 2, and some is there. Again this output is carried out. This is the block representation of full adder circuit using two half adder circuits. Thank you guys.